Welcome back. So today, instead of just working on normal function operations that you've already done, today we're going to dive into a brand new one, okay? Today we're going to talk about the composition of functions. Now, I joke that this is like function inception for those of you that have seen that movie because literally you're putting functions inside of other functions, okay? So instead of dreams within dreams, it's functions within functions. Okay, and that's the whole idea of today is putting an entire function inside of another one. The hint that I give you is start on the inside and work your way out. Okay, so you're going to see notation that looks like this. Okay, and honestly, I always just transform it to look like this. Okay, so when you see F, then open circle G, basically just say, oh, okay, that closer one, that G is my inner function, F is my outer function. So F of G of 2, okay? And the reason I like seeing it that way is because I think it more closely models the way that you would actually naturally think of it. So like I said, I want you starting on the inside, okay? So the first thing is calculating that G of 2. So my G function is this. So if I'm calculating G of 2, I'm just going to plug 2 into that function. So 4 plus 2 is going to give me 6. So now the key to this is now that G of 2 is just the number 6. So I replace that 6 into the f function now. So g of 2 is 6, so now I can take that 6, put it into the outer function, that f function. 18 plus 1 gives me 19. All right, and there you have it. So when you're dealing with just numbers, it's actually not that bad, right? As long as you remember to rewrite it. So here this time g of f of 2. So rewrite it, start on the inside. Now this time the inside is f of 2. So this time the function I'm working with first is that one. So 3 times 2 plus 1. So 6 plus 1 is going to give me 7. And so now in that outer function, since f of 2 is 7, I can just plug that 7 into the g function now. So now I plug it into g. 49 plus 2 is going to give me 51. So when I say start with the inner function, you can see just how important that actually is. Because notice it made a difference, right? F of g of 2 is very different than g of f of 2. Okay? But the idea always remains the same. You're putting a function inside of another function. So let's work with another example. So again, the deal here is I'm always going to rewrite it. F of g of 12. And I'm going to start by calculating that inner function. So g of 12 is just going to be 12 divided by 2, or is going to be 6. Okay? So now that I have that, now I plug that into the f function. All right, so I replace g of 12, I replace it with the number 6, and now I calculate this. So square root of 9, I just end up with the number 3. All right, and for the other one, again, my first advice is rewrite it. g of f of 1. So I start on the inside. Oh, I'm sorry. F of 1, square root of 1 plus 3 is the square root of 4. So f of 1 is just the number 2. So I'm going to replace f of 1 with that number 2 in the g function. So 2 over 2 will just give me the number 1. All right. So in that key concept down below, that's basically what we already talked about. Okay, so that's me just kind of typing out for you what we already talked about together in the notes. So that's how you deal with it when you're just evaluating, okay, when I'm giving you numbers. Now, you can do it also when I give you just the functions themselves, okay? So not evaluating, I actually want you to put the function inside of the other function without any numbers. So let's take a look at what that process looks like. Now the process is the same, okay? The first thing I would do is I would rewrite that notation. I would call this g of f of x, okay? And f of x, well, f of x is negative 2x plus 3. Okay, so I'm actually going to show plugging that function in. So f is negative 2x plus 3. And what I'm going to do with that now is inside the g function. So here, inside the g function, I'm going to put that wherever I see x. I'm replacing that whole thing with that other function of a negative 2x plus 3. So when I'm writing it out, now instead of x there, I'm getting negative 2x plus 3. And I still have that minus 2 at the end. But I'm replacing the x with the negative 2x plus 3. And now I just combine my like terms. And I get that as my answer. Okay, so again, same process, just a little bit more complex now because now you're dealing with more than just numbers. You're putting in the whole function itself. All right, so let's talk about the other way. F of g of x. So f of g of x, well, g of x is x minus 2. So here, now I'm putting in this whole thing into the f function wherever I see the x. All right, so I write out the f function, but in place of the x, I'm putting that x minus 2. Okay, I'm plugging that in into f, and now I have to do whatever it takes to simplify this through. So to clean this up, what that's going to entail is distributing the negative 2 and then combining like terms. And just like when we were dealing with the numbers themselves, keep in mind here that f of g of x is different than g of f of x, right? So do keep in mind that those are two different things that you're going to be dealing with. So let's do some more examples. The best way to get good at this is just the repetition of saying it over and over again so you get a feel for how to do it. First piece of advice, again, always rewrite that notation. I'm going to start on the inside. So f of x is 2x plus 1. Okay? So wherever I see x in the g function, that is going in its place. Okay, so in my g function, instead of an x there, I'm getting 2x plus 1. And something that you're hopefully getting pretty good at is recognizing that when I have to square something like that, okay, squaring something that looks like that is really the same as multiplying it times itself, right? So I would really think of it like that because that's going to help you remember that ultimately you're foiling this thing out, okay? 4x squared, 2x plus 2x is 4x plus 1. Those ones cancel, and so all you're going to get is that. So again, always make sure you're doing whatever you need to simplify this thing out. So let's do this one, f of g of x. So again, this time we're starting in the middle. So g of x is x squared minus 1. Now I'm going to plug that into here wherever I see x. So I'm replacing that x with 2x, or x squared minus 1. And now again, just do what's necessary to clean this thing up. So I'm going to distribute the 2 and combine my like terms. And that's going to be my answer. Same thing in the next one. Again, all these problems work that same way. Once you transition, so here, I'm going to flip my notation, g of f of x. So basically, f is 2x plus 3. So that is what I'm going to be putting into the g function wherever I see x. Okay, so here, I'm going to replace that x with 2x plus 3. And then work from there. So I'm going to have 2x minus 2 all over 2, which will simplify to just x minus 1. Right, because both pieces are divisible by 2. On this side, f of g of x, g is x minus 5 over 2. So in the f function, wherever I have x, instead, I'm going to have that. So 2 times that x minus 5 over 2 plus 3. Now the neat thing that happens here is 2 divided by 2 actually cancels that off right away. Okay, and now over here I'm going to get that as my solution. So again, not horrible. You just have to remember to switch the notation and then make sure you know what you're plugging into what, okay? Start on the inside, work your way out. So let's end with a word problem. So you have a coupon that's good for $5 off the price of any large pizza. You also want to get an additional 10% discount on any pizza for showing your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? So first, we want to find functions C and D, okay? So the coupon. So what is the coupon doing? So what the coupon is doing is it's going to take the price of your pizza and it's just going to take $5 off, right? So if X is the price of the pizza, that's what we're doing, right? We're just taking that price minusing $5. What about the discount? Well, the discount, you're getting 10% off. So if you're getting 10% off, you're paying 90% of your pizza. Okay? So those are the two things that we're working with, okay? The coupon versus the discount. So let's look at composing the functions to apply the discount, then the coupon. Okay? So what that would look like is the discount, then performing the coupon, right? Because you're starting on the inside and working your way out. So the inside is going to be what happens first. So I'm going to take that the discount and then apply the coupon to it. Okay? So what that's going to look like is in the coupon function, I'm going to be plugging in 0.9x. So literally all that's going to do is take 0.9x minus 5, right? I discount the price of the pizza, then take off $5. What about the other way? If I apply the coupon first, so that goes on the inside, and then I apply the discount. So how's that going to turn out? Well, that's going to turn out by taking the discount and plugging x minus 5 into that, right? Because the coupon is x minus 5, so I'm going to take that function, plug it into the discount function. So I'm going to get 0.9x minus 4.5. So I'm going to subtract my functions now. Okay, so let's see how much more I actually would be paying. So 0.9x minus 5, and I'm going to subtract off the 0.9x minus 4.5. So here, those cancel. So negative 5 minus negative 4.5, so basically plus that 4.5, you're going to be paying 50 more cents, okay, if you apply the coupon before you apply the discount, all right? You're going to be spending more money that way because the discount is going to be taking away money from the coupon as well, okay? Instead of the other way around, where the discount isn't going to take money away from the coupon that you're trying to save. So just a fun little application so you can see in the real world how sometimes these compositional functions can play out. So now again, lots of good stuff today, brand new idea, something you've never really experienced before. So you're going to have quite a bit to write about in this summary of yours, okay? About evaluating compositions, writing composition functions, all of that good stuff. So write that summary for me, please, and then come back to class ready to do your practice work.